Now on to page 4. I'm going to do just a quick review of basic revenue cost profit problems that are very simplistic. In example 5, it says a company has initial costs of $275,000 and it costs them $14.80 to produce each sprocket. So we have initial costs and we have cost per sprocket, and then it tells us how much they're selling the sprockets for. Formula for total cost. So total cost C of N will be initial cost plus variable cost, depending on how many sprockets they make. It will depend on N, the number of sprockets they make. So in this case, C of N is the $275,000 initial cost, plus they have to spend $14.80 per sprocket times N sprockets sold. So I see it looks like a linear function, mx plus b form. Find a formula for total revenue. Revenue is price per item times number items sold. So in this case, R of N, the price per item is $26 per item times N, number of items sold. Profit should be the amount of money you bring in, revenue, minus the amount of money you had to spend, cost. And so our P of N function, our profit function, is the entire revenue function, 26N, minus the entire cost function, 275,000 plus 14.8N. Make sure you put parentheses around that whole cost function. You've got to subtract the entire cost. It's important to have those parentheses because now when we simplify this formula, we need to actually distribute that negative. So we're going to have P of N equals 26N minus 275,000 minus 14.8N. And when we combine like terms, we're going to be taking the 26 minus 14.8, and we're going to get 11.2N. So overall, after simplifying, the profit function is 11.2N minus 275,000. Notice this is saying they have initial costs of $275,000. So even when you plug in N equals 0, they'll be down. Their profit will be down in the red, $275,000. And then every sprocket that they produce and sell, they increase profit by $11.2. Identify the break-even point. That means when profit is exactly equal to 0. They're just coming out of the red. So in our profit function, I replace P of N with 0, and I need to solve for the number of items sold in order to make that break even happen. I add 275,000 to both sides. I divide both sides by 11.2, and you can pull out your calculator and divide 275,000 divided by 11.2. I get approximately, let's see, 24,554. That's a rounded value there. They need to sell 24,554 items to break even. They actually make a very slight profit when selling that much because it is a rounded value. A company makes a total profit of 145,620 when selling 8,400 widgets, and they increase profit by $13.25 for every widget sold. We want to find a profit function. Notice this first statement is giving us a point. You plug in N equals 8,400 widgets, and you will get out a profit of 145,620. That's a point on the graph. Input this, output that. And this is a description of the slope. You increase profit $13.25 for every widget sold. If you go over one widget, you go up $13.25. Sounds like this profit function is a straight line with a constant slope. Over a widget, up 13.25. Over another widget, up 13.25. So we have a slope equal to 13.25. We have a point on the graph, so we can use the point slope form of a line. Remember, that's y equals m times x minus x1 plus y1. You plug the slope in for m. You plug the x value of the point in for x1, the y value of the point in for y1. So in our case, the y is p of n. That equals the slope, it's 13.25, times n minus 8,400 is the x value of the point, plus 145,620 is the y value of the point. So in this case, our x value is really n, and our y value is p of n. The slope is 13.25, x value of the point, y value of the point. Now you can go ahead and distribute if you like. If you really like to write your equations of your lines in slope-intercept form, that's fine too. If you distribute that 13.25 and simplify it down, that's fine. You will get P of n equals 13.25n plus 34,320. That's just an alternate way to write it. Revenue at Acme decreases by 4.2% for every dollar they raise the price. So you go up $1 price, you decrease a fixed percentage, 4.2%. Remember, behavior like this is exponential. They're saying we have an exponential function with a fixed percentage rate. In this case, the function's decreasing, so the rate is negative 0.042. Recall, exponential functions have the form a times b to the x, where a is your y-intercept, your starting value, and b is the factor. To decrease at a rate of 4.2%, factor is 1 plus rate, so it's 1 plus negative 0.042, which is 0.958. To decrease at a rate of 4.2% is to say that you're taking 95.8% of the previous y value. So in this case, it's y equals, the y-intercept, the starting value was 45,000 items sold. The factor's 0.958 raised to the x. Now in this case, x is dollar price. So you would plug in, for example, a price of $0 when they're free. Then they will sell 45,000. Plug in a price of $1. Now the price went up, so they sell less. When you plug in the price X, it's spitting out the number sold. It's not spitting out revenue, which is what they want us to find, but it's spitting out number sold. If you want to find revenue, that needs to be number sold times price per item. So this function right here, y equals 45,000 times 0.958 to the x, is plugging in price, spitting out number sold. Revenue, we need to take that, the 45,000 times 0.958 raised to the p, the price. That is the number sold, and then we need to multiply that whole thing times p, price per item. Here's the number sold, 45,000 times 0.958 to the p. Then you multiply that times the price. That's the total revenue. When XYZ Company hired a new general manager, they found that the revenue increased by 1.8% every month. So it says R of M, we're going to plug in. M is months after they start. R of M will give us revenue. And they said they found revenue increases 1.8% every month. So you go over a month and you increase 1.8% in revenue. Again, this is exponential. We have a fixed percentage increase. In this case, they said the rate is positive 0.018, 1.8%. So our factor is 1 plus rate. In this case, then, our factor is 1.018. Revenue was 1.9 million in the initial month. So R of M is your initial revenue, 1,900,000 times 1.018 raised to the M power. Plug in a month. For example, if month is 0, you'll get your starting revenue. Plug in another month, it will be multiplied by 1.018, so it will increase 1.8%.